How many of you are looking forward to macro support in stable Dart? Yeah, me too. Has anyone tried it already? No? Yeah, a few hands. Looks exciting and promising, right? To be able to update some Dart code and immediately have the generated code update accordingly. Magnificent. However, as of now, this feature is in experimental state, and there is no clear roadmap as to when it will land in stable. In addition, this feature works in combination with packages, and it is another time-sensitive dependency. Clearly, tasks like JSON deserialization or data classes enhancements is the one that is getting a lot of attention from the community, and support of macros is already available for early preview. However, for other tasks like dependency injection, navigation, REST API consumption, it may still take time to migrate, if it makes sense to migrate at all. And in addition, it's still unclear whether the interface of this feature will remain the same when it lands to stable. So, to my point, it's not something you can go and confidently apply in your serious real-life Flutter applications for now. But you know what is? Yeah, good old Build Runner. Have you used Build Runner? Yeah, a lot of hands. I was hoping for that because this talk is primarily going to be useful for people who have experience with Build Runner, have leveraged its benefits, maybe felt some pain. Myself, I use code generation with Build Runner quite a lot in my daily life, and I cannot stress enough how big is an effort it saves me from daily. However, maybe you also notice this. When the usage of code generation is extensive and the project grows, over time, it introduces some challenges like slower code generation execution time, merge conflicts, analyzer performance downgrade, and some other. So Build Runner is a tool that helps us to be productive, but the way it is working, we also have to be helping it to help us to stay productive. So over the years, I developed certain practices about efficient maintenance of the code base, which uses code generation a lot. And that will be our primarily focus today. But for the inclusiveness of this session for folks who are not quite familiar with Build Runner, but also for better understanding of some of the key points I will be making later, I will spend a few minutes explaining key principles of Build Runner, and then I also share code generating packages that I find particularly useful and apply daily in my day job. But bear with me, very soon we will move on to best practices for efficient code base maintenance. We'll talk about speeding up code generation process, minimizing merge conflicts, and overall improving developer experience. But before we continue, in case we haven't met, this is me. I'm active in various communities and also on social media, where I primarily talk about Flutter development. I'm Google developer expert in Dart and Flutter. And currently I work as a senior staff engineer in the UK fintech company called Tide, where we create mobile applications for our huge financial services platform using Flutter. And by the way, Tide is constantly hiring senior Flutter developers. So let's start with Build Runner principles. In a nutshell, is a tool that provides an extendable mechanism for generating some output files from some input files. And developers can create code generators that leverage this mechanism to read any file of a package, typically Dart code, and produce corresponding output files, also typically Dart code. And this allows us, users of those code generators, to specify only the minimum configuration for the desired code, launch code generation, and have a lot of valid boilerplate Dart code generated. And next, we'll look into several examples of such generators. But first, let's see how to use build runner. First, you have to add it as a dev dependency to your pubspec YAML file. And next, we can launch it with this command, dart run build runner build-d. At this point, build runner triggers all code generators that are added as a dependency, and it provides them with all relevant files of your package as an input and allows them to produce corresponding output. Build runner has two modes. Build is for one-time generation. It is useful for when, for example, the code is checked out on the new environment and you need those generated files, or, for example, when a code generating dependency was updated across the project. So one-time generation is sufficient in these cases. And it also supports watch mode, which monitors the file system and instantly updates output files as soon as the input files changed. Watch mode is useful for when developers are actively working on some package. And the D parameter here is short for delete conflicting outputs. It is a recommended one. It silences prompts that build runner may show when it meets the generated files it believes it didn't create. At this point, it's important to realize that build runner on its own, it does not generate any code. It allows generators to do so. And now let's look at common development tasks and packages which work in combination with build runner. I won't go deep into details of each of those in terms of usage or benefits because we are limited in time, but the goal is just to highlight a few of them that work quite well for me and raise awareness, because some of them are quite popular, but I believe some of them definitely deserve more attention. Probably a package that needs no introduction, right? JSON serializable. It allows annotating Dart classes with special annotation, and it generates to JSON and from JSON serialization methods based on the list of fields in this class. Compared to the original JSON, you can change field types, field names, even structure. But there is a ton of information about it online, including the resources I created, so I won't spend more time on this. Check it out online. Next, once again, quite popular code generating package, Freest. This one generates useful implementations of equals, hash code, toString, and copy_with methods. And it also suggests functionality similar to sealed classes and pattern matching. What's nice about it is capable of working in combination with JSON serializable, and it will use the code generated by JSON serializable. Once again, very popular package, a ton of information online, so moving on. The next package is useful for implementing RESTful API consumption. With retrofit, you can generate methods that will use DO, obtain data via given paths, query parameters, or path parameters, and parse this data from JSON in just one line. And if instead of DO you prefer using HTTP client, there is a good code generating alternative called Chopper. Injectable is quite useful for projects that use Getit as a service locator for dependency injection. So instead of teaching Getit how to create all of the dependencies manually, you can instead annotate them with special annotations, lazy singleton, and injectable, and then after code generation is executed, you will have this method generated, and Getit will know how to create all of your dependencies. Afterroad is a package that uses code generation for implementing strongly typed navigation. You can annotate widgets with road page annotation and have a road with strongly typed parameters and return type generated for you. And Afterroad also does support named and nested navigation, so quite nice. Next is the Fluttercon package. It comes handy when your package has some assets like images or fonts, because by default you have to access them by file name, which is error-prone. And instead, this package, when configured, it generates a Dart class which has all of your assets as fields with proper paths, which you can then use in your code and be confident that file name is correct, the asset is there, and there will be no runtime errors. I like to use i69env package for managing translations. So you can declare your translations in YAML file, and after the code is generated, it creates Dart file with the same fields. But what's nice about it, it supports placeholders and plurals. And once again, you have compile time checks that the translations exist, that the format is correct, and so on. A quite interesting approach for documenting and testing your code can be applied with BDD widget test package. So it allows to describe your feature requirement in natural language in Gherkin style, and then the corresponding widget tests are generated. This is how your typical counter application can be tested with widget tests. So this approach guarantees that documentation is always up to date with the actual implementation. And the last package for today is the one I recently released myself. The barrel file package allows you to generate barrel files for your package based on this include in barrel file annotation that you place right on top of your code that should be exposed from the package. Now, if you apply all of these packages I have just mentioned in a serious big Flutter projects, and that's what I do, it will indeed save you a lot of time and effort for maintaining and writing those boilerplate code. However, maintaining generated code also requires some attention. So now let's talk about practices that will help you minimize this effort. First, let's focus on speeding up the code generation process. As we already saw, build runner runs all generators that are added as a dependency to your package, and it provides all the relevant files from your package as an input. So naturally, the number of generators and the number of files in the package impacts the time it takes to generate code. And depending on the project size, it may take from a few minutes to over an hour. So to speed this up, we can limit the generator's input. And the first way of doing it is to create a special build YAML file next to your pubspec YAML file. This file allows configuring all of the code generator's behavior, and it supports a special generate for parameter, which accepts a list of names or file masks, which will be served as an input to a particular generator. In this example here, we instruct JSON serializable to only run on certain files and folders. And by the way, this is also a nice way to ensure the structure of your package is respected. Because if, for example, you place your models outside of this list, meaning violate the predefined package structure, no code will be generated. However, you have to remember it will not be generated without any warning or error. So it might be confusing at first. So this was one of the ways to speed up the code generation, but still, despite minimizing it in build YAML file, if the package is quite big, for example, the entire application is in one package, it will still take a lot of time because the input is still big. So to make it even smaller, it makes sense to split the project between packages. Because when we launch code generation, we launch it in one package at a time. So the smaller is the package, the faster the generation completes. But honestly, I recommend this approach not only for the sake of speeding up code generation process. Overall, this approach provides better encapsulation, faster tests, and overall reduced cognitive load. And additional benefit of this approach becomes obvious when using code-generating packages like injectable or auto-road, as opposed to freezed or JSON serializable, which generate one output file per one input file. These generators produce one file per package. So if multiple developers are working on the same package, these are the files most prone to having merge conflicts. And obviously, the smaller is the package, the smaller is the chance for merge conflict. With this approach, most of the time, you need to run code generation in one or few packages only, which are being actively developed. But still, there are situations where you need to run it on the entire project, and Melas is a tool that can help you optimize it. This may be required, for example, when you update a code-generating dependency across all of the packages in your project. So once the tool is installed, you can write custom scripts in Melas YAML file in the workspace root directory. In this example here, I create a script called generate, which launches code generation in all packages that depend on build runner. And then this script can be executed with Melas run generate. Now, if you follow this practice to the extreme, you may face analyzer performance downgrades. Because the more local packages the project has, the bigger is the load on the analyzer. I can share that from my experience on the project with over 400 of packages, analyzer takes from 13 to 30 gigabytes of RAM, after which I just have to kill it and it starts over. But there is this setting to instruct the analyzer to only look at the files in the package which currently has open files. Of course, it may not always be feasible to use this setting. It depends on the tasks you are performing, but quite often it helps. And by the way, the rumor has it there is a nice analyzer performance improving coming out soon. Staying on topic of Dart analyzer, we all know that Dart static analysis tool can be configured in a dedicated analysis options file located next to pubspec YAML file, and every team can configure it to their likings and needs. They can pick one of the predefined sets from pub.dev, or they can create their own set from all available rules. However, such flexibility imposes a challenge for code generators because they cannot possibly meet all of the requirements you have configured in your project. Some packages, like Freezed, already take care about this with special analyzer instructions on top of the file, so they will not have any warnings. But for the rest, the generated code may become quite a source of quite a number of warnings. And this causes clutter, and it makes it hard to notice real problems. So the easiest solution to this is to instruct the analyzer to ignore generated files. This is done again in the analysis options YAML file. Here I listed all the extensions generated by the packages I mentioned before. I have to admit that in rare cases, it may be useful to have these files analyzed, but for majority of cases, it works just fine, and excluding generated files from analyzer also improves the analyzer performance, which is a frequent problem for large-scale projects. So the next recommendation is about limiting the number of times you actually need to run code generation. I have a feeling this is the most asked question in the community. Do I commit generated files to Git? My recommendation is to do so, and to prove my point, I like to suggest a thought experiment. Imagine you work in a team of several Flutter engineers on some serious Flutter project, and following the previous advice, you actually split your big project into smaller packages. So And finally, if you don't commit generated files to Git, what happens when a newcomer joins the team or your teammate gets the new development machine? They check out the project, they have to run code generation because it is currently in compilable state because some of the code is missing. What happens when you pull updates from remote repositories that your teammates did and run the app, face unexpected behavior? How do you know if it is a bug or if it is just your locally generated files became out of sync with their configuration? And how do you know which ones? You have to run the code generation in the entire project to figure this out. And finally, what happens when you automate release builds or PR checks on CI? The first thing it does, it checks out the code and has to run code generation again. And all of this time is not free. It is your time, time of your colleagues, time of CI runners. Again, from my experience of the project with over 400 packages, we use Melas to generate code in packages consequently, and it takes about 2 hours to generate code for the entire project. Now, what happens if you do add code generated files to Git? The project is always in compilable state, right? Well, almost always, because at first you and your team members will be forgetting to add them to Git, but this is something that will fix itself over time, and committing generated files will become a habit in a matter of months. If you do add generated files to Git and 2 developers work on the same project, you have a likelihood of having merge conflicts. That's true. However, if you follow the practice of splitting the project between smaller packages, the likelihood of those is smaller. And when you face merge conflicts, well, you know exactly which package they happened, and running code generation in that package to just override the conflicts takes a few minutes. You don't need to rerun it in the entire project. But keep in mind that when you add generated files to Git, your repository will grow in size quickly. Still, given all of the above, I'm on the side of committing generated files to Git because it saves developers time, and that is the priority for me. Now, since generated files are added to Git, they have to be reviewed during PR review, right? But frankly, most of the time, you don't really need to check them. So they can be collapsed by default. For GitHub, this can be configured in .attributes file. GitLab supports similar configuration, but the syntax is slightly different. Here I listed all the extensions, file extensions that should be collapsed by default. So this is what PR would look like when you just open it. And you still can review all the files by clicking load diff, but generated files are nicely collapsed by default, and they don't distract you from your reviewing the main changes. The same problem is valid for showing generated files in your IDE. By default, these files are displayed in the project tree right next to your regular files, cluttering the view. But fortunately, all IDEs support organizing generated files by hiding them under the main file with the same name. To configure it in VS Code, you have to go to Settings, Features, Explorer, and turn on file nesting. And then you have to configure your Dart entry under file nesting patterns. And for Android Studio, this is configured on per project basis. So you go to project options by tapping those 3 dots, and also open file nesting and configure Dart entry. Now, the most popular way to specify package dependencies in pubspec YAML is by using the caret syntax, right? When you run build flutter pubget, the pubspec.log file next to your pubspec YAML file kind of logs the exact versions of the dependency that is now used on your machine until you don't explicitly update it. The version locked can be either the latest matching from your local pub cache, or if it is not available, the latest matching from the pub dev. And this log file gets created on every developer machine when we run Flutter pubget. And we have an advice to not to commit these files for non-application packages, which is the majority of them. So we may end up in situations when different development machines have different versions of generators. And sometimes it may happen that these different versions of generators produce slightly different code. So if two developers end up in the situation and work on the same package, they will be overriding each other's changes with no particular reason because the configuration itself didn't change. So to avoid the situations, I advise to always specify the exact versions of all code-generating dependencies without caret symbol. And it clearly goes without saying that all packages across your project should use the same versions of dependencies. And Melos tool I mentioned earlier can help you with this task. Another case where we may end up with different generated code depends on the code generation order. For example, if we use JSON serializable and freezed to generate our data classes and JSON deserialization, the toJSON method is not generated until those two generators are executed. In turn, a retrofit package would decide whether to generate the call to that toJSON method based on the existence of this method in the code. So naturally, freezed and JSON serializable have to be run before retrofit in order for retrofit to produce the correct code. Once again, generator sequence can be controlled in build YAML file. In this case, freezed generator is executed first, then JSON serializable is executed, and then retrofit generator runs last. Most code-generating packages offer flexibility to configure generated code. This can be done globally for a package in build YAML file. However, there may be situations where you want to apply different configuration to generated code inside a single package. If it is a rare case and you just want to configure one or two model annotations right where it is used, you can do it right where it is used. However, if the number of such cases is significant, you will have to repeat this code over and over again, and it is suboptimal. But instead, you can extract frequently used annotations to its own constants and then reuse them on top of your unique models. Next advice is quite a simple one. Extensive usage of code generation leads to frequent launches of the process, so it definitely is worth creating some shortcuts, and frankly, you can have them whatever you like. Here is just an example of aliases for Unix-based systems. The first two aliases launch code generation in build or watch mode. The third one executes Flutter pubget, which is sometimes required before launching the code generation, so the later two aliases just combine these two tasks. Usage of some code generating packages like injectable or barrel files is as easy as applying one annotation. However, other packages like freezed, for example, require memorizing special syntax. And to optimize this task, you can configure code snippets, or they're also called live templates in JetBrains products. It's a multi-step process, so I recently published short step-by-step tutorials on how to configure those on my YouTube. And once configured, you can just type a few symbols, like in this example, I have a snippet called fmodel, and you hit enter or tab, and you can immediately start typing the name of your class, or if you configure it even further, the class name is taken from the file name. So here, the cursor is already conveniently placed in the constructors, you can immediately type the field names. And finally, let's talk about tests. Test coverage is one of the metrics commonly used for evaluating code quality, right? In Flutter development, we can easily generate a test coverage report by running this command, and by default, generated files are included in the test coverage report. Unfortunately, not all of the generated code can be covered with tests, and for not all of the code, it actually makes sense to cover it. But since they are included in the report, it affects the overall coverage percentage. And the simplest way to address this issue is to exclude generated files from the code coverage report. So once again, Freest already takes care of it, but for the rest, this can be done with the help of Remove from Coverage tool. After it is installed, we can instruct it to manipulate the report file and remove generated files based on their extensions. This way, your code coverage percentage measures only the coverage of the code you are actually interested in. So this is a list of the best practices we talked about today. We covered speeding up code generation process, configuring Dart analyzer, managing generated files in Git and in IDE, and discussed various practices that overall improve development experience. Of course, depending on your project siz's needs, some of them might be more helpful than the others. Only pick those that make sense for your project and solve the problems that you are already facing. Here's also a QR code with a link to my article I recently published at Code with Andrea platform. And I'll leave this slide up while I answer your questions. Thank you.